Oh, all right. I'm ready. Don't worry. Brilliant timing because I'm hello. I'm Daniel. I'm Captain Square, but I'm a confused person. Jeez, I'm a confused person, and I can rarely remember who I am and what I do and everything. So when I hold workshops, I have this short video that I like to show the participants that helps explain who I am, and it also helps me remember it. So I'm going to show that video to you here. And of course, I've heard that the videos don't work so great. So if the video is not working so great, then there's the link to the video so you can watch it at your own leisure. And here's the video on the screen. Hello, I'm Captain Credible, creator of the Microbit Orchestra. Over the years, as a musician and maker, I have made countless different musical instruments, ranging from musical helmets and candle-powered synthesizers to wireless robots and self-playing circuit boards. Some of my instruments work really great. Others work also not so great as the ones that work really great. By making my own musical instruments, I can decide to a much further extent exactly what the music is going to sound like and what it is going to look like when I play the music in front of people that are looking at me. This goes for all tools you make, not only musical instruments, but hammers and nails and fake nails and other things as well. What I'm trying to say is that being able to make things that you can use to make things with is really great, and I want to teach you how to do that. That's why I've made the Microbit Orchestra, and using the Microbit Orchestra you can make robots and make code easily that can play music and bang on things and send radio messages. And it's, you want to control a robotic xylophone by touching bananas? It's okay. You can do that. That's okay. It's not hard. It's easy. And it's quite fun. Okay, so that helps me at any rate, and it might not help a lot of you, but it helps me remember a little bit who I am and what I'm doing. And so basically, I think what I was trying to say in the video is that I'm a musician and artist, and for me, like a really important part of being a creative person, you know, somebody that creates art, is has been to create the tools that I make art with, because I've been a musician for at least 20 years now, and I've also, you know, made a lot of you know, sculptures and art in other fields as well, not just music. And, you know, everything from like club concerts to contemporary arts festivals, which was actually the most recent concert I played, was at the Oslo Contemporary Arts Music Festival. Sorry, Festival of Contemporary Music in Oslo. Ultima Festival it's called, where I actually used Microbit, the Microbit Orchestra, a bunch of robots to play the piece. It was a piece for 34 speakers and about 50 robots that was all controlled using Microbit. Sorry. So Basically, I've always created my own tools when I make music, and it became very important for me from quite an early stage in my musical career. And it had the reasons I started making it aren't really the reasons that I continued making it, because to begin with, it was a little bit out of necessity. Buying music gear is expensive, and also because I wanted to make different music. I wanted to be for a start, I was making music on a computer, and basically making music on a computer back then, the way you were supposed to perform that was just like sit behind a laptop and press play, and then let the beats come out of the speakers and then check your email and play Minesweeper while the crowd kind of enjoys your music. And I wasn't really interested in doing that. I wanted to play music in a more kind of explanatory way and be a little bit more engaging, both for my own sake and for the audience as well. So and in order to do that, I felt I had to create my own instruments. And so this is kind of what it looks like. It's a bit loud. That's what it looks like when I play a concert. You can see that there. It's also actually a concert I played using loads of microbit robot things. That's an installation as well. That's an installation in Tromsø, in the museum in Tromsø, the science museum in Tromsø, that they use for both concerts like that and for educational purposes, for teaching kids to program, because it's all microbits hanging on the wall. Then anybody can program their microbit to send radio messages and control the microbits on the wall. And yeah, so this is quite late in my career as a musician. I think I've got some pictures here, of what it kind of looked like in the olden days when I used to build musical instruments. This is when I was a kid. This is the oven from the wall in the flat that we moved into. It's a bit yellowed because the guy that owned the flat before us died from cancer, because everything was yellow in the flat, covered with thick layer of yellow. And then over the years, as I've been making all these instruments, of course, I put a lot more thought into what the hell I was doing, I guess, and I also ended up teaching a lot of people how to build musical instruments. And for me, by then, it had become the important aspect of building these instruments was to try and take control to a certain extent over the creative process, because I realized quite early on that the music, or what you create with music or in any creative form, or even if it's not creative, even if it's not an art form that you're working with, then the result of what you make is determined in part by the creator or the composer in the musical situation, and part by the tools that the composer uses, and often almost equally much, depending, of course, on how you evaluate it, equally much affected by these two different things. And then, of course, the third thing that I always, at least that I always thought was important, especially for music and compositions, is the audience, or the people that are experiencing the piece of art or the creation. And it's very evident as a musician, as soon as you step on stage and start playing music in front of people, that the reaction to the people and the I mean, I hate to use weird words like the energy in the room, but the interaction between the artist on stage and the audience plays an enormous role in the music that's created. And of course, the interaction between the musician and the tools that he uses. So I started using this step of creating tools as a conscious part of the creative process when I was making music. And I also ended up teaching a lot of other people how to build musical instruments and how to build electronics, because other people saw what I was doing and thought it was interesting and wanted to try it for themselves. So as of studying things, I only ever studied like phonetics and fine arts and things that aren't really 100% related to the kind of stuff I ended up doing. And I'm self-taught in electronic, and really largely in music as well. I mean, I had piano lessons when I was a kid, but apart from that, I didn't really study a lot. But for me, I found out that when I was creating these tools, when I was learning programming and learning electronics, I was far more motivated by the sort of allure of learning a new skill and being able to create something that I wouldn't be able to create if I didn't learn this technology, if I didn't grasp how these things worked, as opposed to being told that you have to learn something, or learning something to solve an explicit problem that somebody has given you, that you have to learn JavaScript because I've told you to make a web page and you have to make this thing move, for instance. For me, it really works a lot better if the goal for learning something is that I'll be able to create something that I wouldn't be able to create if I didn't learn this skill. And I realized that this was also working for other people that I was teaching, that if the incentive to learn something was that they'd be able to create with what they learned, then people are a lot more interested in actually understanding and learning these new skills. So yeah, I'm reading notes over here. So I was very interested in this relationship between the artist and the tool and the audience, and I like to call it the point of interaction, which is where the kind of the artwork or what is being created appears in the point of interaction between the artist or the composer, if it's a musician, and the tools and the audience. It doesn't really live in any of the other places, and I've really brought this into my artistic process in a lot of very explicit ways as well. As I mean, when I release music now, I always release music on circuit boards, and the circuit boards are like this one right here, which is a circuit board where the person who buys the circuit board plugs it in, and let's just skip to the bit where they plug it in, and when it's plugged in, it generates music by itself. But it also invites the user to push these different buttons and to create their own melodies and rhythms and make their own music. Let's see, is that explained? Yeah, like I'm trying to do there. Let's see over here. Oh no, maybe there we go. Here I'm making a melody on the device. So if I'm the user making a melody on the circuit board, which is the music that the artist has released, then I'm, as an audience member, participating in a very great part. But then on top of this, the circuit board itself, it's every time you turn it on, it makes a new song. It's just got algorithms that I've written, and it uses those algorithms and random numbers to create completely new music every time you turn it on. And when the user that has bought this EP release, basically this musical release, starts interacting with it and pushing the buttons and waving in front of the light sensors, then of course the user is also controlling the music and making the music and becoming a collaborator in the artwork. But then the device itself, this circuit board, will occasionally delete things that the user has used. So if I'm a user and I bought this and I'm making a melody, then the circuit board will sometimes change the melody that I've made, or remove some notes, or add some notes, or transpose, or sometimes just delete everything and starts fresh, which then puts the actual circuit board and it's sort of AI. Of course, can't call it AI. It's just an algorithm. It's not very complicated at all, but it's unpredictable, and it itself, the tool, is very much taking control over the work of art, the finished product, so to speak. So for me, it's always been important to be able to sculpt the process here of my own creative process. Sorry, and take control of the creative process by building the tools. And I realized that this translates really well, in my mind at least, to what I was doing with these workshops as well, where not only was this a great incentive for other people, but the tools that I was using to teach these workshops were also very instrumental in how I was teaching. So in the same way as I can see an artwork being the sum of, or the point of interaction between the composer and the tools and the audience, then the teaching, or the emergence of knowledge in people happens at the point of interaction between a teacher and his pupils and the tools that he uses to convey the knowledge about about what he's talking about. I mean, for music, the obvious example would be like playing a guitar. The composer is limited to playing 6 notes at a time, and if he's playing in front of an audience that is the mosh pit where people are headbanging, then he's not going to play, classical music. Very likely. And in the same way, it's very difficult to convey the meaning or the underlying nature of mathematics without using an abacus or without using stones you can count with or without using your fingers. The tools play a very important role in being able to create knowledge in people. I'm an artist. I don't know if you noticed. I'm not like I'm not an educator of soul. So a lot of what I'm saying probably sounds very philosophical and out there. But yeah, let's have a look at stuff I've done then with this artsy fartsy way of thinking about how to teach people and how to create stuff. I've got some links here. Yeah, so I already kind of introduced the microbit orchestra in the beginning there with that little introduction video, and there is an installation in Oslo that you can actually go online. I can post the link to that as well in chat. You can go online and kind of interact with let's see, how do I open this link? There we go. Interact with this kind of 3D installation of the installation that is in Oslo in their Teknoteket. What is it? Technolob. Sorry, Jon. I can't remember. In one of their spaces for teaching. So here you can see like the classroom with all the students there, and then on the wall here there's different robots hanging around that play music, and in this interactive map you can kind of move your finger over different things and get a little kind of demonstration of how the different robots work and what they do and whatever. So this is a tool that's used both for my own sake for creative expression. I've written music for this installation and others, and also as a tool to teach programming and electronics and music. So the backbone of this is kind of the microbit orchestra programming. What do you call it? The microbit extension is what it's called. Microbit orchestra microbit extension that looks like this, where you have all these blocks for making things. Some things are simplified a lot to be able to convey musical concepts. Like this is a little step sequencer that if I load it onto a microbit like this one here, wait a minute, like this one here, then let's go like this. Then this step sequencer, these two step sequences are now synchronized to each other because like there's a master clock in the room, and then I can like make the sequence in this, and then that will be played on. Let's turn this camera on so you can see. So there's a robot over there playing it, and it'll play in sync with, of course, other things. But this isn't really what I was going to talk to you about today. It's just kind of the, what do you call it? The framework, or the where I am now and why what's happened now has happened. Because I'm a huge synth nerd, as probably several people that are watching here can agree with. And I mean, I could show you other videos of installations and different things I've made. And actually, let's have a look at this. I made some robots. Sorry, I'm not sticking to the script here, am I? If I got it, no, how this does not work. Wait a minute. There, go to the page, put it there, go like that. Here are some other robots that I made to teach programming, where kids can build these little rabbits. And the little rabbits sit on things and drum. But of course, you all remember this because I did this in England, in Manchester, some years ago, where I played a concert and these rabbits were playing along. So I don't need to explain all this stuff. Instead, let me show you something cool, because like I was saying, I'm a huge synth nerd. And well, that's why there's all these synthesizers behind me, which I like to play on as much as possible. And for me, being able to, it's like understanding music and sound is very integral to what attracts me to mathematics, I think, really. So I've been thinking for a long time, is it possible to do this stuff on the microbit? And for a long time, it hasn't really been possible. And believe me, I've tried really hard to do like proper synthesis on the microbit version 1, and it wasn't happening. Well, people have managed to do it, but what I want to do is I want to be able to do the synthesis, and I want to be able to control it using mate code. You know, I want kids to be able to use this brilliant IDE, this programming environment, and make music on synthesizers. Or make synthesizer music with the microbit. And as you all know, the microbit is limited to playing one note at a time, and that note is a kind of annoying square buzzing note. Or is it limited to that? Because what I've managed to put together with the amazing help of Tom Johansson from Notam, who is a brilliant programmer that has really dug into the nitty-gritty guts of the microbit to make this happen. Here we have a what's called a subtractive polyphonic multitimbral synthesizer with sample playback support running on the microbit. So let's try. And so what I've got here, right on the left, is it says a bunch of things like set preset user 1 parameter oscillator shape to 0, set preset blah blah blah. And basically what I'm doing here is I'm programming in what the sound is going to sound like. This is not what it's going to look like in the end. There's going to be both sounds that you can just choose from, like different cool sounds that you can choose from, or and a much more user-friendly interface for making your own sounds if you do want to learn how to make sounds. But what I've basically done here is I've set up a synthesizer voice called user1 to have all these parameters, and then I can add this trigger note. Let's use this to play a note. And let's start with 69, and then let's trigger the note, but let's also give it a pause. I might not, this is like, I don't want it to last for a second. Let's say 200 milliseconds. And add pause. After it's 500 millisecond pause, let's say. And now I'm going to download this to my synthesizer. I've started calling it a synthesizer. It's a microbit, really. Which is here, and as you can tell, I've connected 2 crocodile clips to the microbit's 0 and ground pins. And when I click download here, then hopefully we should get a note coming out of the microbit when it's done. It takes a bit of a while to compile the first time, often, but luckily we have. Oh, there we go. And now it is playing a note, which sounds, I don't know if you agree, but I think this sounds a lot nicer than the notes used to sound on the microbit. I'll just turn that down a bit. And let's try to play another note as well at the same time as the first note. So let's play another note that is note number 74. At the moment, it's just note numbers. Later, there'll be more of a graphical interface to do this. So let's also, I always forget to do this, or I always like to do this. Let's add like a little symbol here so we know what's been downloaded. We download this to the microbit, and there we get our plus. And it is playing 2 notes at the same time. I hope you can hear these notes because they're beautiful. But we don't have to stop at 2. Let's add another one. Let's add one that is note number 81, for instance. Download that. That was an octave above, so can't really hear that very well. Let's add another note, shall we? Let's add note number 90 on top of that. There we go. Should we add another one? Let's add another note on top of these. These are 1,000, so we're starting to lose notes now because these notes are lasting for a whole second and then they're being re-triggered every half second, so we're getting twice as many notes being alive at the same time. But if I cut it down, we should be able to hear them. I think this is amazing. And then of course I can change this. Let's say we want this oscillator to be, or let's say we want this oscillator to be a triangle wave instead. Let's say we want this to be twice the frequency of the first oscillator. Let's say that we want it to last much longer, so a release time of 1 second. And it's doing that. I forgot to point out, because I've just got so used to it now, but all of you probably noticed that this isn't working in the simulator at all at the moment. And every time I change some code, I get error messages down here. Their program error, cannot read properties, blah, blah, blah. So for now, this code is basically made to work in on the actual hardware, and we haven't really set up a way to simulate it yet. And the big question is whether we'll end up simulating it or whether we'll end up with an emulation, or how we're going to do it is for later. For now, I want to show you some other cool stuff I've made with this. Let's see, because I've only had this for for a little while. I've not had a lot of time to play with it. Here's one called accelerometer filter, which tries to play several things at the same time. Actually, before I do that, let me show you the drums. Of course, why not? Because they're pretty easy to use. Let's just add a play sample bass drum with gain 1, which is like on basically, and then let's put a pause in after it. Of course, let's pause for 500 milliseconds again and download this and see what that sounds like. Oh, turn the volume up, sorry. Okay, let's add some more drums. Let's add like some hi-hats. Play sample hi-hats. And then another pause. And then play sample snare drum. And then another pause. And then play sample another hi-hat, I guess. And then that's it. Let's just do that. Oh, I set the gain to 0 on all of these. Like, so that's why we can't hear the rest, because they're all set to gain 0. Let's set gain to not 10. Set gain to 1 on them. And then hopefully we have a beat. I like it. Don't know if you guys like it, but I think it's great. Let's see what else we can do. Let's see if we can get some music going here. So this, basically all these purple things here are setting up the synthesizer voices. And this one's going to be using 2 different synthesizer voices at the same time. So 2 different sounds playing different things. And then I've got this thing here that, what is it it's doing? This is like playing some notes and waiting and then playing, and then adding 2 to the note that is being played. So it's kind of an algorithmic composition, which is also something that I think is very interesting to teach people when they're doing programming, how you can use algorithms to create art that creates itself, basically. Let's just see what this does. And over here we've got another forever loop that basically just gets the acceleration data and changes the parameters of the synthesizer every time it does that. Ooh, I wonder what that's going to sound like. Let's download this and look at. There you go, algorithmic house music. All it took was, I don't know, 50 blocks of code. But that's not all. Let's try something else. Because this does work, but after a while, I don't know if it's done it yet. No, not yet. After a while, these different kind of sequences that you saw I'd set up will drift out of time with each other because of the way the timing in the microbit works. So here's a, hello, Megan. Here's another one where running background compass. Let's just try this. I've just got a few more examples to show. Is this me getting kicked off, Megan?
No, you still have a few more minutes, Daniel. Please keep going.
Downloading. Oh, what? Oh, yeah. I have to calibrate the compass. Come on. Hello. Yes. To fill the screen. Yes. All right. There we go. This is, there we go. There, there, there. There we go. All right. Now we should run. Oh, yeah. I remember this one. So the way this one works is if I hold in the A button now, and then I add the bass line. If I hold in the B button, then I add the chords on top. And then I can change the filter of the chords by tilting it up. And then I can even press the logo here to change the drums. And then, oh, the compass direction is modulating the whole music. So that's an example of how you can control the synthesizer in real time while it's playing polyphonic sounds and multi-timbral, meaning that it's playing different types of sounds at the same time on top of each other, which is, I think that's cool. And then this last one here, which is called Jingle Bells, which is just one of those tedious experiments in what happens if I sit down and try to make jingle bells by chaining blocks after each other. And it looks like this. This is what Jingle Bells looks like as blocks. There's a lot of them. There could be more. This isn't all of Jingle Bells. This is just a little bit of Jingle Bells. So let's download this to our... Oh, wait, you didn't see that. There's Jingle Bells. Sorry. And then if I thought, oh, that's a cool sound, but what happens if I change this oscillator to a square wave and instead of transposing it up by multiplying it by 2, what if I multiply it by 4 and then just download this again? How does that change the music? And I've made a completely different timbre. There we go.
Daniel, I hate to interrupt, but you have about a minute left. Everyone is loving
I'm finished.
What you're doing. I know someone in the chat was asking if you had some code or extension that you could share.
It's very much work in progress. So it's hidden away on a GitHub, and I don't think we're going to release it until we've made it work a little bit more properly. I mean, as I was saying in the beginning, it's like all the technically difficult stuff. I mean, this is a proof of concept, basically, really. It's now we've proved that you can do a synthesizer on a microbit and get it to work with everything else. So awesome. The next steps are setting it up in a sensible way, because it's not set up in a sensible way at the moment. The making a sound is cumbersome.
Well, everyone will be waiting for that. So thank you so much. I think you've inspired a ton of people today. I know that everyone, the keynote is wrapping right now on the main stage if everyone wants to head there. But thank you so much, Daniel. That was so cool. Everyone was in the chat dancing, having fun. So I really appreciate your time today.
Yeah, thanks. Thanks for having me. Have a nice day.
Bye, everyone.